let's talk about isotopes, because the truth is that every atom is an isotope. And when we're talking about elements and atoms, we're really talking about isotopes. What we're used to looking at on the periodic table, if you're looking at the periodic table, is the weighted average mass. The weighted average mass is something that we will be looking at, but like 12.01 or 15.99 or 1.008 aren't whole numbers. And in nature, you're not going to have 0.5 of a proton or 0.6 of a neutron. You have to have 1 proton or 1 neutron. So when we're talking about isotopes, we're really talking about elements or atoms with the same number of protons, but they have different amounts of neutrons. Those differing amount of neutrons change the mass of isotopes. And that mass number is going to be added after the element. So if you see carbon-15 or C-15, we're really talking about the isotopic mass being 15. If I'm looking at my periodic table right now, carbon, there can be carbon 12, carbon 13. Those are the two main ones. It can be carbon 14. There's two types of hydrogen, hydrogen 1, hydrogen 2. So you have to be told either how to determine the isotopic mass or be given a way to find it. Isotopic masses are always whole numbers. They are not the weighted average that's on the periodic table. They'll always be a whole number. So how do we find the number of neutrons or the isotopic mass? There is a formula for that. So the formula is number of neutrons equals mass number minus atomic number. The mass number is something that you have to be provided, and the atomic number is on the periodic table. This is what you look up on the periodic table, because the atomic number equals the number of protons and electrons. So another way of looking at this would be mass number minus protons, or mass number minus electrons. Now, these aren't ions, so they're going to have the same number of protons as electrons. So if you're given protons, you know that it's the same number of electrons, so you can always back into it. If you're given the number of neutrons, so you can look at something like mass number equals protons plus neutrons. There's different ways of organizing this equation, and it's really important that you understand that these three pieces make up the necessary information for an isotope. So let's look at this more in depth. Oops, I went the wrong way. So elements, we're gonna be given an element, we're gonna kind of break it down because this is something might you see. So CS-133. So first you gotta look up CS because this is an atomic symbol or an atomic element symbol. So CS is short for cesium. So when you look up cesium, you can see that the atomic number is 55. This just tells us how many protons and electrons there are in one atom of cesium. That 133 tells us the mass. There's two different masses that we use in chemistry. It's either grams per mole or AMU. We primarily use grams per mole in this chemistry class, but especially in this unit, we might use AMU, so please watch your units. So how we would approach this is if we were given this, we would know that our mass is 133, and given that we know the element, we can tell how many protons and electrons there are. So 133 minus 55 gives you 78 neutrons. But you might be told, what is the isotopic mass of the isotope of cesium given 55 protons and 78 neutrons? Then you would just add 78 plus 55 to get your mass number of 133. Let's look at it a different way. SB121. SB, that's short for antimony. Look up antimony, you see that the atomic number is 51. This 121 is the mass number. So we could look at mass as either 121 grams per mole or 121 AMU. Now, Either one of these is acceptable until you're given a specific unit to use, and then you do have to use that specific unit. So 121 minus 51 is 70, or you can go find the mass number by adding 70 plus 51 to get 121. So these three parts all go together. You have to be given two of these parts to find the third. You always have to be given two of these parts to find the third. So ZR 94. ZR is zirconium. If you look up zirconium, it has an atomic number of 40. That gives you 40 protons and 40 electrons. That 94 is my mass number. That's either 94 grams per mole or 94 AMU, depending on the units you were provided. 94 minus 40 gives you 54 neutrons, or you could do it the other way. 54 plus 40 gives you a 94 mass. So let's look at what an AMU is. So when we're looking at an AMU, it stands for atomic mass unit. So A for atomic, M for mass, U for unit, and that is defined as 1/12 of a carbon atom. It's the atomic mass of an element is the weighted average mass of the isotopes. So when we're looking at the atomic mass on the periodic table, and the reason that it comes in partial numbers or decimals instead of whole numbers is because it's a weighted average, which we will look at later. So when we're talking about what AMU actually stands for, remember we were talking about relative masses. So the electron has an AMU of 0.00549. Proton and neutron basically have an AMU of 1, and that's where we get the relative masses from. And that's, in a nutshell, the basics of isotopes.